It is time to look at one of the best ways for getting larger amounts of data into your programs or saved out of your programs, and that is files. So, to back up and think about the computing term, a file is information that's stored in some secondary form of memory, where programs that are running are in primary memory, and things like variables inside of those programs are also in primary memory, often also called RAM. But we're talking now about secondary memory, things like hard drives or USB drives or things like that, that are a part of your computer's set of devices that can store data, but are not that primary set of memory where running programs live. Files can store all kinds of information in lots of different ways, many different formats. The easiest format to work with is a text file, or at least the easiest to get started working with. Many other formats will provide you features that a text file definitely could not provide you, but with those features will come some extra tools or libraries or structures that you might need to work with them. For instance, many people think that, say, a Microsoft Excel file would be really neat to work with, but because those can store formulas and graphs and lots of other different metadata about the information that's stored in the file, they often take extra work, extra libraries or tools or plugins or things like that to deal with. Text files contain only text. Now, that text may represent numbers or names or URLs of web pages or things like that, but it's stored simply as text, strings. And so that makes it very easy for us to start off working with and possibly build ourselves up to other types of files, say image files or, again, Excel files, stuff like that. Some of the uses that you may encounter for files, well, storing things long term, because as you may have noticed, variables go away when you close your Python session or you in Jupyter reset your kernel or things like that. There's a good chance that if your program stops running, the data that you had in it is not going to be accessible anymore. But files are intended to store things longer term. They can also be really helpful for getting large amounts of data into our program by reading it from the file without having to hard code it directly into the program. So long strings typed into your code that make your code hard to read, and you would have to modify your code every time you want to change one of those strings, or without having to type it as input each time the program runs. You don't really want your user having to type in all 5,000 grades that they want included in the final grade sum that they're trying to do for a student. You might want to be able to have that saved to a file and then read it in from the file and do some work with it, do some math or things like that. And it provides a data storage location that multiple programs can access and modify, though we should be careful about that. For example, if those two programs both have the file open at the same time, this needs to be very carefully coordinated, or it can cause very big problems. But this allows us to do things like pre-process a file in Python, where maybe the code that we have to write for it is very short and very easy to handle, and then maybe feed that into a more complex program. You'll see this quite often, especially in uses of Python, where Python is used to kind of clean up things or do some of the plug-in type of things in games, for example. And then the main program might be written in some other language like C or C++ or Java or something like that. And so those different programs, even in different languages, could communicate in a way by one program saving some information in a file and the other program opening and reading that file, and possibly back in the other direction too. So in Python, files are treated as sequences, just like a string or a list or a range or the keys or the values from a dictionary can all be treated like sequences, looped over and things like that. Then a file can be treated as a sequence too. And this is part of the Python philosophy. In Python, one of the design ideas behind the language was to have these shared structures, these shared patterns to behavior, wherever it makes sense to have them. So it makes sense that you could just write a for loop to go through a list the same way that you could write a for loop to go through a file. The difference is where lists have elements and where strings have characters, files have lines. If you use them as a sequence in Python, then you'll be looping over the lines in the file. So the lines themselves will be sequences of characters. They will be strings. You'll get them as strings. But understand that you're not looping character by character. You're not stepping character by character as you get things from that file. You are stepping line by line unless you specify otherwise. There are ways to step more than a line or less than a line. We'll see some of those, though not all of them. There are plenty of different approaches you can take too. But the default, if you just do like for L in file, is you will get one line at a time. Before you can use a file in Python, you need a way to refer to it. The way that we do this is we create a file object. We create a file that we could name as a variable by opening that file, and there are functions for that, which we'll see in a moment. We can then read from the file and possibly write to the file, depending on the settings. And when we're done with the file, we close it. So here is about the simplest example that you can get of using a file in Python. We open a file named dnf.txt, it's not the full word text, and we can specify how we want to open it. There are defaults for this, but it's probably smartest to say specifically, are you opening it for reading? Are you opening it for reading and writing, etc.? So in this case, we've given R as the type of access we're going to do, which is read access. We can view it, but we cannot edit it, and that's safe. That makes things safer a little bit. If we know we're not supposed to edit it, then we could say specifically, I really only want to be able to read this, and then you won't mess anything up by accidentally writing to that file. So we saved it as a variable, or we named it as a variable is another way to think of that. We named it my file. Then we say myfile.read. This will actually give you the entire contents of the file. So I told you that if you treat a file as a sequence, you'll get it line by line, but the read function will give you the entire file all as one long string or short string, depending on whether the file is short or long, but one string. That string will include new line characters in it for each of the line returns that was done in the file. And then once we've read all of it, we really don't need the file open anymore because we could have saved all of this as a variable. Probably should have saved it as a variable, something like contents equals myfile.read. But this is a really, really simple example where all we did was we just opened it, read through all of it, didn't save that, possibly not the smartest move if we're going to use that data, and then we close the file. It's not strictly required that you close every file. Your program will probably run just fine, but many operating systems have a limit on how many files can be opened by a single program at once. So if you were opening files for every student in the class, for example, once the class sizes got large enough, you might run out of allowed files that you're allowed to have open at a time. And so it is politest and the best idea for yourself to close those files so that those system limits aren't reached. Here's another way to read it, which I hinted at before. Because it is a sequence, it's a sequence of lines. I often will name things line when I'm looping through the things in a file, unless I have some much better name that's specific to what kind of data is in the file. This reminds me that what I'm getting is a line, not a word, not a character, but one whole line. So here we've opened the same file. We've given it the same name, my file. Now, one nice thing about doing this loop is that we're now dealing with the line variable. We don't have to do things like myFile.readline or things like that over and over again. We just have the line variable there. So all this would do is print out all of the lines that were in that file, dnf.txt, with some dashes in between pairs of lines. And then it closes the file. So mostly the same as the other one, except for here we're repeating back what was in the file with a little bit of separation so that we can see that this is separate lines. One thing to note is we haven't really done this before in our previous print examples, but you can tell print not to print a new line. So here, this would print the dashed line with a new line after it, but then the line from our file would not have a new line after it. So the next dashed line would start directly at the end of our file, or at the end of our line from the file. This can be helpful for identifying whether there are spaces at the end of the lines from our file or other characters we can't see right away, like tabs or stuff like that. Very helpful in debugging when you're getting one extra character that you don't know why it's there. So we can tell print what to end its printing with. And if we say empty string, that means just print the line, no new line or anything else after it. And so this is a different way to use print. It actually has more options that we haven't used. And it's worth looking into if you're interested in doing different ways of printing stuff. Okay, we've looked at reading files, but what about writing to a file? If you have a bunch of information that your program has generated, say it's generated locations for where all of the opponent characters are going to be in a game map, and you might want to save that. For instance, if the player wanted to save their game and quit right now and be able to come back to it later. So we can open a file and we just open it in a different mode. Here we're opening it in a write mode. So then we can write things line by line or entry by entry. For our purposes, we'll almost always write one line at a time. So we'll almost always be adding that new line after whatever we've written. But in some cases, you might be writing, say, a student first name, last name, ID number, and grade before you write that new line or stuff like that. So you may or may not end up doing lines in the future, but for our purposes in this class, you'll mostly be writing a line's worth of data and then a new line character, and then you'll be kind of done with it there. And you'll move on to the next data, next data, next data. This loop here assumes that there is some list called cool data items. So we have to sort of assume there was some code before here that generated that data or something like that. And similar to when we were reading from a file, when we are done writing to the file, it is best to close it. This both makes sure that nothing else gets written to that file that we didn't intend to, and cleans up those file handles, those file allowances that we have, and makes room for us to open another file if we want to. You can, if you want, use print to write to a file as well. So this is another of those options that print can do. You can specify to print what it should write to, or what it should print to. And you can tell it, I would like you to print to this file instead of the standard system print that you see. That's referred to as system out in some other settings, some other programming languages, and some other approaches. That prints to what's called the system out or system output. When we do input, by the way, that's often referred to as system in or system input. So we can tell print, don't print to that system version, print to this specific file. And that way we could just tell our data to print there and give it a specification of, oh, you're not printing to the system, you're printing to this file. Here is one more way that we can read from a file that may be useful if you kind of prefer to work in lists, or if you're wanting to hold on to the data. That read command that we did at the start, it can be useful if you know that you really want all of the file all as one big string. But often, if there are multiple lines in the file, you might want them as a list. And rather than having to do a for loop and have an empty list and accumulate item by item, you can just call readlines, and it will do that for you and create a list, and then you can save it in a variable. And so here all this has done is open a file with read permissions, save all the lines of it as a list. Each one is a separate string in that list. The new line characters, by the way, are stripped away. Just like when we do split, the spaces or whatever we split on gets stripped away, the same is true here. And then here in this example, we're printing out that whole list. Obviously, much of the time we would want to be taking every item in that list and adding one to it, or something, some other thing that we want to do with all of this stuff that we just saved in that list. But this is just a simple example where we get the data and then we could print it all out and we would see all of those items line by line. Now, or stored at each line, but they would be stored in a list. So it would print out in list format with the brackets and then each string with a comma and a space between them. Okay. One thing that's important to understand as we go through files is that we have a position in that file. And this might make sense to you, especially in regard to lines. After we read one line, our position is the start of the second line. And after we read the next line, our position becomes the start of the third line. Similar to if you're reading through a book and you put your finger where you're currently reading, that's your position. Well, files have the same basic concept. As we read through the file, that file handler keeps track of our position of where we would read if we asked to read again. What would be the next thing we would get? So each of those various file reading operations move us through the file by some amount. There is a readline function that reads the next line in the file. This is similar to what our loops would do. Each time we go through the loop, it's like we called readline. It would step us in our position one line further through. So if we use readline several times, each time it reads the next line and changes our position to the start of the following line. So this example reads the first line, prints it, reads the second line, prints it, and then closes out the file. So at the time that the file was closed, the position would have been the start of the third line of the file. Now that won't matter anymore because we closed the file. If we reopen the file later, our position will be the start of the file again because we're opening it fresh at that point. This position concept becomes important to understand, especially if we're doing commands like read, which we might expect would read the entire file for us. But if our position is not the start of the file, then we will not be reading the entire file. We will be reading from the current position to the end of the file. So here we get the first line from the first call to read line. We get the next line from the second call to read line. Then we get the third through the last lines from this read call. So if we expected it to be holding the entire file, we'll be wrong and it will be missing 2 lines that we might have expected it to have. So tracking the position as you're structuring your code, remembering where the position would be, is pretty important in those kinds of cases. It can be especially tricky if we ask to read more than once. For instance, here we open the file, we get the file's contents, and by doing myfile.read, once we do that, our position will be the end of the file. And you may remember that my description of read was very specific. It is from the current location to the end of the file, from the current position to the end of the file. After the first read, the position is the end of the file. So the second read will get from the end of the file to the end of the file, meaning that its result will be an empty string. So we'll think that we have stored the contents of that file twice. Maybe we want like the original and one that we're going to modify. That's fine, and there are ways to do that. This is not it. This will get us an empty string in this second situation. Here is the way that we could actually read the file through fully twice, and that is by using seek. It will change our position. So we've done the same thing we did before. File contents is myfile.read, and then we've done another myfile.read, but before we did the second myfile.read, we reset the position to the beginning of the file, position 0. So we called myfile.seek and told it 0 is where we would like to be. And then we told the file to read again, and so we will have a second copy of the data from the file, and our position will be at the end of the file again after that second read. So seek can be really useful for going back to a position that we had been at. It also can be used to move relative to your current position, or move relative to the end of the file as well. You could advance to the last line, for example, by seeking relative to the end of the file. And you'll want to look up more details of the seek function if you want to do anything a little more advanced like that, changing relative to something other than the start of the file. So to review, we've seen a few different methods for files that we can open a file, giving it a file name and a mode like read or write or read-write. We can read the whole file, read a line, read all of the lines and get a list, write to a file, seek to a different position in the file, and close the file. And I want to reiterate, much like the input command that we've used before for getting user input sort of from that system input, everything we get from the file will be strings. If you want it to be treated as an integer or a floating point number or a Boolean or anything else, you need to take that chunk of string that you have from the file, and you need to ask Python to convert it to an integer or a floating point number or a Boolean or whatever you're wanting to be dealing with. And that will be quite common because, of course, we might store integers in our file, but understand that when we get them from the file, they'll come to us as strings, and it's our job to confirm that they're correct in the correct format and to convert them to the right type that we want to be working with. We also saw a couple of hints of ways that the print function can be used differently than we've seen it used before. We can tell print how to end its printing, either nothing, therefore not having a new line, or with other characters if we wanted to. We also can tell print where to print its information to, such as printing things to a file, and this can replace write function calls. One other thing that I want to take a moment to point out that's not directly related to files, but may come up as we get to more and more complex data, is we've said before that you can return one value from a function. And that is still sort of true, but it turns out we actually can return a single grouping of values. These come out as a special type called a tuple, which is just a fancy word for any collection of multiple things, multiple entries, elements, whatever, that is immutable. There are much deeper concepts that you can get into if you get into more theoretical understanding of data structures and of programming languages, but for our purposes, they come out kind of like a list, but you can't change index 0 or things like that. So what we do, if we want to return, for example, a pair of values, like the sum and the product of two numbers, we can return those in one line with a comma between them, which this is sort of like how you could have returned all along a list that contained the sum and the product. As I said, the difference between these is that the grouping is immutable. What you get out can't be changed at index 0 or index 1. And we can do these neat things where if we know two values are coming out of this math combo function, the sum and the product, we can actually store those as variables in one line. We say calc sum, comma, calc product equals math combo, called on some values here, 7 and 8. And then we could do things with the sum and we could do things with the product. They are actually two separate variables in this example. And so that's kind of a neat thing that we could do. We could return multiple values from a single function. It uses this underlying idea of a tuple, which we don't have to dig too much deeper into. But what you can be aware of is if you know how many values are going to come out of it, then you can create variables to kind of catch those separate values coming from your function. There is actually no limit on the number of values that something can return because you can grow that tuple to as large of a size as you want it to be by just putting a comma and another value you want grouped in that return and another value and so on. The order on them will matter very, very much. If you are returning multiple values, you should make sure to very clearly document for anyone who uses your code that there will be multiple values and they come out in this exact order. Or otherwise the person will get things, they'll know that the sum and the product come out but not know which one is which when the two of them come as return values. In practical terms, if you're returning more than like 2 or 3 values probably, it's often better to reconsider the design of your program and maybe split it into multiple functions or create some more complex type like we'll see later in the course to be able to hold all of those different values in a way that's a little smoother and a little better encapsulated. But it can be very useful to know that you can return multiple values from a function using this simple structure of simply putting a comma in between the different values that you want returned, and that you can catch those multiple values into variables by putting a comma between those variable names on the left-hand side of the equal sign. And as I say, as we get to files and as we get to bigger and more complex amounts and types of data, it may become more and more useful to be able to have a function that gives out multiple values like that.